All right. So this is our 68, 95, 99.7 rule worksheet. And at first we're going to talk about skew. So if you look at the bulk of the data, the skew goes towards the tail. So this first one is going to be right skewed. And a right tail has a larger effect on the average than it does on the median, because those people are really heavy. So adding an extra person here, or whatever we're looking at, that will affect the median, but it will only bump the median over half a person. But because that person is very, very tall, they are going to drag the average in that direction. So in this case, we have right skewed, and the average is larger, and then the range is just going to be 100 minus 0, which is 100. Okay. The next one is not skewed. That's actually called bimodal data, but you don't need to worry about that. And then we look at the bulk. So I would say that is the bulk. And so this is sort of like a tail. It's going to pull the average in that direction. So the median is larger in that one. And then of course, if you have a normal graph, the average and the median are in exactly the same place. Okay. So on the next set, we have a graph, and I told you the rule was 68, 95, 99.7, and it was a bit of a lie. It's actually 68.2, 95.4, and 99.7. So if you use those numbers or you use 68, 95, it doesn't matter. Okay. So this first question asks, what percentage falls between -1 and the mean? So it would be this chunk of data here. Well, this is 68, so that must be half of it, which is 34. Okay. What is the percentage of the data that is greater than 2 standard deviations? So that's going to be all of this stuff here. So what percentage is between 2 and -2? 95%. So what would be in the two tails? 5% total, which puts 2.5 on the right. Does everybody get that? This is hugely important stuff. So if you understand this, life will be much better for you. What is the percentage of the data that is less than 3 standard deviations from the mean? So that would be this chunk. So that is 99.7. So the two tails in total must be 0.3. So the left tail is going to be 0.15%. Now that is not 15%. That is 15/100ths of 1%, which is almost nobody. Right? So if you are 3 standard deviations or more from the mean, you are extremely rare. Those people just don't happen very often. Between the mean and 2 standard deviations. So what's that going to be? Half of 95. So 47.5. And I think the answer is on the back. They're according to the 95.4, right?
No,
they're not.
Whatever. So the specific answers.
And again, this is never perfect. So if we expect 68 and we get 71, we say, yay, we won. That's close enough, right? If we expect 95 and we get 91.5, that's pretty close. So none of these are perfect. Okay. I'll move this eventually. Between 1 and 3. So this chunk here how are we gonna do that? There are lots of ways to do it. So this is 99.7, right? And this is 68. Okay, so we want to, I got the hiccups, it's not good. So I'm going to divide this in half. And that gives me this area, right? So 99.7 divided by 2 is 49.8. And that would be that area. And then I could just subtract 34. And I get 15.8%. Okay? Do you guys understand the rest of them? Do you want me to go through all of them?
Yeah.
Okay. And there are lots of ways to do this. You could, another way to do it is figure out how big this is, figure out how big this is, figure out how big that is, and then just add those two together.
That's what I did.
Lots of different ways you could calculate that. Between -2 and 1. So between here and here. So we know that this is 68. So now we just need to figure out how big that is. Well, if I look at 95 and I subtract 68 from 95, so that's, what is that, 27? What does the 27 represent?
Both sides.
This chunk and that chunk. So take 27 and cut it in half. So each one of those is 13.5. So if this is 13.5, then I just add those two together. Okay? Does that make sense? Where are we on 17?
Yeah.
-3 and +2. So from here to here. So that's going to be 95. We'll take care of this. And then we're going to do the same thing. 99.7 minus 95 is 2.7. And that is split evenly between this one and that one. Oh, 4.7, sorry. So I cut 4.7 in half, 2.35. And what do I do with the 2.35? Add it to 95. Does everybody understand that? Okay. 18. Outside of 1 standard deviation. So everything that's not in there. Well, 68 is in there, so not in there would be 32%. So you have a 32% chance of landing either there or there. Between -1 and 2, between here and here, so this is 68, and we decided that that is half of 95 minus 68. What was that? 13. 13.5. And then we would add those together. Alright. And lastly, greater than 1 or less than 1. That's the same as 18.